Hello, everybody. We're back at it. Here we are with Essential Math, grade 9-10. And it's Mr. Stone coming back at you from the interwebs. All right, so we're on activity 5 now. We're going to take what we did in activity 4, looking at proportions, and we're just going to extend it into solving problems using proportions. So going from word problems to proportions and then solving them, just like we did the last time with that same technique. So just a quick recap here. Remember how we solve proportions. Anytime we have remember, a proportion just means something like this. Two fractions that are equal to each other, and one of the four slots, one of these four spots here, is blank, is unknown, right? And we have to find out what that is. So it's two fractions equal to each other, these two sides, two fractions, and we have some unknown that we want to know. And to get that unknown, the trick is we always multiply along the diagonal. Okay, we multiply those that we know on the diagonal, and then we divide. After that multiplication, we divide by that fourth number. Okay, so it'll be 3 times 10 divided by 4. So that unknown will always be 3 times 10, so that was on the diagonal, 3 times 10. Right, that was my diagonal, and then I divide by that third number, divide by 4, and that'll work out to 7.5, and it'll always work. Okay, this technique of multiplying across the diagonal and then dividing will always work. Okay, I still remember learning this. I think first time I saw this was in grade 5, when my math teacher showed us this little trick here, and I still remember it to this day. So let's try a problem here. A nice word problem here. So it's going to be a whole bunch of words. I'm going to read it out to you here. So Julie is a member of the environmental club at her high school. They just completed a study on the recycling habits of paper and plastic. They're trying to determine how well the school recycles paper and plastic. They used a ratio to reflect their findings. Amount recycled compared to, see this little column here, that's a ratio. So we have recycled compared to the amount thrown in the garbage. So it's recycled to garbage. So recycled to garbage, okay? That's the ratio. So for paper, the ratio ended up being 5 to 2. Okay, so that's 5 recycled for every 2 in the garbage. For every 5 pieces of paper they found in the recycling bin, there were 2 pieces of paper in the garbage. And the ratio for plastic was 1 to 2. For every 1 piece, so that was for plastic, paper. For plastic, it's 1 to 2. For every 1 piece of plastic recycled, there are 2 pieces of plastic in the garbage. Okay, so we have these 2 ratios. Paper is 5 to 2. Okay, and remember that the first number is recycled. So this is recycled is 5, and garbage is 2 for paper. And for plastic, recycled is 1, and garbage is 2. Now the question here is, Friday is recycling day at Julie's school. All classes bring their recycling products to the custodian at the back of the school. The environmental club found 90 plastic pop bottles in the plastic recycling bins. Okay, so that's what they found. They know that there were 90 plastic pop bottles in the recycling. 90 in the recycling. Use the ratio from their study, 1 to 2. So using the ratio from their study of 1 to 2, remember that was recycled as 1 and then 2 in the garbage. How many pop bottles could they expect to find in the garbage? So for every 1 that they find in the recycling, they should find 2 in the garbage. So let's make this proportion. Okay, so let's rewrite the first thing we need to do when we solve these problems is we have to rewrite the ratio as a fraction. Okay, so instead of writing it side by side, we're going to write it on top of each other. So fraction, right? So we're going to write that as 1 over 2, not 1 colon 2. We're going to write it 1 over 2. And I'm going to write next to it here, recycled over in the garbage, just to remind us that the top number is recycled and the bottom number is garbage. Okay, so that's the first part. We have our ratio that we know. The piece of information that we also know is that we have 90 pop bottles, right? So we have 90 plastic things in the recycling. So 90 is in the recycling. So we got to remember that that 90 now is going to have to go in the spot with the recycling. And remember, recycling is on top, garbage is on the bottom. So I'm going to rewrite, I'm going to put the 90 here on the top because we said 90 is recycled. So the 90 is going to go in the top slot. And then our unknown was how many was in the garbage. That's going to go under here. So we have this proportion, right? And we now have to solve that. And remember, we have our technique to solving proportions. We multiply along the diagonal, and then we divide. We multiply first along the diagonal, and then we're going to divide by that third number. So our unknown, how many plastic bottles in the garbage, is going to be equal to 2 times 90. That's along the diagonal, and then divided by 1. So it works out to 180. And that makes sense when we think about it, right? We said the ratio is 1 to 2. For every 1 bottle that we found in the recycling, there should be 2 in the garbage. Okay, so that's telling us that for however many we have in the recycling, we have to double it to find out how much we have in the garbage. If we double 90, we get 180, which is exactly what we got, right? And remember, this is a word problem. And anytime we have a word problem, we start with words, we translate it into math, and then we translate it back into words. So we write a therefore statement. So therefore, there will be 180 plastic bottles in the garbage. It's very important that we take what we do on our math, right? X equals 180. That doesn't really mean anything. We have to translate that back into what the actual meaning of 180 is. 180 was the number of pop bottles that you'd find in the garbage. So, therefore, there will be 180 plastic bottles in the garbage. And there, that's done. And so the tricky part here is setting up this proportion first of all. Once you get that, we can follow our steps here, multiply along the diagonal, divide by the third, and we'll always get it. But the problem is getting this one here. Okay, so let's do it again for paper. In their study, they found that 500 sheets of paper were discarded into the garbage each day. Okay, so there's 500 pieces of paper in the garbage. We have this ratio, using the ratio from the study, 5 to 2. And remember, that was garbage to recycled. How much paper is recycled each day? So first step, let's write out the ratio that we know. We know 5 to 2. So I'm going to write that as a fraction again, 5 over 2. And I'm just going to write down next to it, remember that the, one second. Sorry, I apologize. There was a typo here. So it was 5 to 2 recycled to garbage. So for every 5 pieces in the recycling, there was 2 in the garbage. Okay, so we can write that as 5 over 2. Okay, that's the ratio that we know. Okay, we also know that there's 500 sheets in the garbage. So where am I going to put that in my next fraction here? It's 500 in the garbage. Remember, garbage was on the bottom here, right? Garbage is on the bottom, so I'm going to have to then put 500 in the bottom. Right? 500 is in the bottom of our, 500 is in the bottom of our fraction here, right? 2 represented garbage, right, in our ratio, and we know that there was 500 in the garbage. So we have to put 500 in the garbage row. Right? The top row is the recycling row, and we don't know that yet. So here we got 500 in the bottom. So now we have this nice proportion. Right? So once we get to that step, it's pretty straightforward. We just have to follow the same rule. Multiply across the diagonal and divide by the other one. So that's going to work out to 5 times 500. So we're going to multiply 5 times 500, and then we're going to divide by 2. And that works out to 1,250. Right? Remember, this actually means, if it's unclear, right? It's 500, and then we divide by 2. Having this fraction over 2 is the same thing as dividing by 2. And there we go. Last thing we have to do, remember, for word problems, whoopsies, just want to erase that, is a therefore statement. Okay, so therefore there'll be 1,250 pieces of paper recycled. And that makes sense, right? So a ratio tells us there's more recycling, right? Because 5 is bigger than 2. There's more recycling than garbage, right? We know there's 500 in the garbage, so there has to be more in the recycling, right? So we got a bigger number than 500, so we're good to go. Good check at the end of it is to see if it makes sense. Okay. One more example here. Okay, gas mileage. Okay, this is a good ratio that you see a lot of. Okay, so Mr. Stone has a 2021 Toyota Corolla, and it has the following gas mileage. Okay, so whenever you buy a car, they'll always tell you the gas mileage in a certain way. They're going to have highway mileage, so that's driving, in a straight line, mostly at the same sort of speed, mostly, and city where you're going to stopping and starting, it's accelerating, decelerating, foot on the gas, foot on the brake, that uses more gas, right? So in the highway, it says that my car uses 6.1 liters of gas for every 100 kilometers that you drive. Okay, so there's a nice ratio, right? Every 100 kilometers that you drive on the highway, you're going to use 6.1 liters of gas. But if you're in the city, right, if you're driving in the city, stopping and starting, hitting red lights, hitting stop signs, the gas mileage is going to get a bit worse, right? Instead of using 6 liters, it's going to use 7 liters for every 7.1 liters for every 100 kilometers. Okay, so this is how in Canada we report the gas mileage of cars. In the States, you may see there's something miles per gallon. We don't use that unit, but that's another way that gas mileage is measured. But here in Canada, we use metric system, so we say liters per 100 kilometers. Now, I'm going to drive to school, okay, and it's about 50 kilometers for me to drive to school. I live on the other side of Smith Falls, just about near Perth, so that's about 50 kilometers, almost exactly 50 kilometers. So at least that's what my car tells me. How much gas do I have to use? That's one way, right? You can have to double it to get the whole round trip, but let's just go the one way. So what am I going to do? I'm going to write, now let's assume, because most of it's Highway 43, it's pretty much entirely highway driving. The only time I get stopping and starting is driving through Smith Falls, Merrickville, and then a little bit of Kempville. But really, most of it is highway driving. So let's just assume that I drive highway the entire way. So let's use the 6.1. And we can make a fraction from my gas mileage, right? I'm going to use the highway numbers, and I'm going to say 6.1 divided by 100. Okay, so that means 6.1 liters of gas. So the top number is how much gas I use, and the bottom number is how many kilometers I've driven. Okay, so now I've got this ratio that I know. The piece that I don't know is how much gas I use. All right, so I don't know the top number. I'm going to get a second fraction, right? Proportions are always two fractions equal to each other. I don't know the top number, so I'm going to write that as x. I don't know how much gas I use, but I do know the distance that I'm going to drive. And I do know that I'm going to travel 50 kilometers. Okay, so this is where you might make a mistake, where you have these guys upside down. So just make sure that you just check that the numbers mean what they think they mean, right? So I get x, my unknown, over 50, and now I just have to solve it. Remember, the trick to solving it is we multiply across the diagonal and then divide. So we multiply across the diagonal and then divide by the third number. So again, this is going to be 6.1 times 50. That's my diagonal. And then divide by 100. And that works out to 3.05 liters. So Mr. Stone, I, will use about 3.05 liters of gas to drive to North Grenville, if we estimate that it's entirely highway. I think my car, it tells me, and it's about 6.4 liters that I use on average. But whatever, we're gonna estimate highway driving here using this ratio they gave us. Okay, using 6.1. Okay. So this is how we can calculate, given a ratio, we can calculate any gas mileage for any distance. So here was for 50. Let's try it again for a larger distance. Let's say I drive to Thunder Bay. Driving to the Thunder Bay is 1,500 kilometers. It's a really long way. It might take you 2 or 3 days maybe to get to Thunder Bay. How much gas are you going to use to go 1,500 kilometers? So exact same idea, right? So we're going to write down a ratio that we know, right? Let's assume again, I'm going to go highway. It's almost entirely, I'm going to take Highway 17 almost the entire way. So we're going to assume, um, we're going to assume highway driving the entire way. So 6.1 liters per 100 kilometers. So that's what this says. 6.1 liters of gas is used for every 100 kilometers. That's my ratio. I know that there's 1,500 kilometers I'm going to drive. So in my next fraction, I'm going to put the 1,500 in the kilometers row, right? The bottom here is all the kilometers. So 1,500 goes in the bottom. And what I don't know is how much gas I use. So that's going to be my unknown x. So once I've set it up, right, that I don't know how much gas I'm going to use, I'm going to put that in as a variable x. I do know how far I'm going to go, so I'm going to put that in the bottom, because that's the distance row is on the bottom, the gas row is on the top. Now I just have a proportion that I need to solve using the exact same trick. Multiply across the diagonal, divide by the third, and we get 6.1 times 1,500 divided by 100, and that works out to 91.5 liters, 91.5 liters of gas. So Mr. Stone will use about 91.5 liters of gas to drive to Thunder Bay, which I think, if I think about it, I think I can get about 700 kilometers for a tank of gas. So that's about 40 liters. So I'm going to have to fill up twice. I'm going to have to hit 2 gas stations along the way so that I can actually get to Thunder Bay. Okay? So that's filling up twice. Dollars wise, that would be about $130, I'm guessing. Yeah, it's about $120, $130, $130 probably. Maybe 100. Gas prices are a little bit higher out towards that direction, so probably about closer to $130. Okay, so there we go. There's two examples of how to use. Well, I basically did 4 examples of how to use proportions to solve problems. Okay, so we're going to use these examples to help us do our assignment. And the assignment is very similar to what we just did. We're going to have to solve some proportions. Just these are, these don't really mean anything. They're already set up for you. Remember, we multiply along the diagonal and then divide by the third, and that gives us our answer. There's 3 of them. Let's just go find here's the assignment. So there's three proportions that you have to solve. Remember, multiply across the diagonal, divide by the third. Multiply across the diagonal, divide by the third, and we're good to go. Then there's 2 word problems. This one, again, and just another one of these environmental club ones. This time looking at cigarette butts either in ashtrays or on the ground. So there's a 2 to 5 ratio. For every 2 cigarette butts you find in an ashtray, you're going to find 5 on the ground. I see I missed a bracket. Apologies. So that's the ratio. For every 2 cigarettes that you find put into ashtrays, there's 5 cigarette butts on the ground. Okay, that's a ratio, 2 to 5. Using that ratio, answer these 2 problems. It's very similar to the problem we did on recycling versus the plastic and paper recycling, whether in the recycling or the garbage. So almost the same. So if you get stuck on these ones, go back to those problems. And then number 3 on the next page is a fuel consumption one. Okay, so this is looking at a 2007 Pontiac Vibe, which has a fuel consumption of 8.2 liters per 100 kilometers for city driving. So same problem there. And then it gives you a problem for highway driving. Okay, we got 2 problems to work on there for for gas consumption, and 2 problems for an environmental club again, and then some just regular proportions. And that's it. Okay, once you solve that, again, you can print this off, solve it by hand, scan it, send it to me, or you can write it directly onto this. This is a Word document. I'm going to post this right now, and we'll go from there. All right? Awesome. All right. So managed to get this under, well, just over 20 minutes. So hopefully I wasn't too long. Thanks for your time, and thanks for all your hard work. All right, guys? You guys are doing great. I'll be talking to you later. Take care.